Hello. Welcome back to our afternoon session in the summer school. This session is associated with the focus on memory institutions here in the libraries and archives and the galleries. So many of these institutions, they want to automatize some of the tasks that they do. And there is a movement in Estonia to make these for government institutions, for libraries, archives, and they are called KRATT or KRATT. KRATT is an automaton from Estonian folklore. Are you going to talk about what is KRATT?
Yeah, I can talk.
Okay, good. Then we'll leave it to you.
Yes.
So it will be an example of what can be done with this memory institution data. And the presenter is Linda Freienthal, who works at TEXTA now, which is a text analytics company, startup in Estonia, working on Estonian language text mostly. And she herself has a background in computational linguistics. She finished her master's last year in Tartu University and now works as a data analyst, computational linguist, whatever needs to be done at the company. But please.
Thank you for this introduction. So today I'm going to talk about a KRATT that we did in National Library of Estonia, in TEXTA. And KRATT is, who doesn't know, in Estonian mythology, a magical creature. Essentially, KRATT was a servant built from hay or old household items by its master, who then had to see 3 drops of blood for the devil to bring life to the KRATT. The KRATT was notable for doing everything the master ordered. Therefore, the Estonian government uses this character as a metaphor for AI and its complexities. So KRATT is a program that does what we command them to do. And for beginning, I'm giving you a little outline, which you must know that libraries use Estonian subject thesaurus, or in Estonian Eesti märksõnastik, for labeling their books. And it is a universal controlled vocabulary in Estonian for indexing and searching various library material. And it has English translation as well, and you can see it covers various topics, and in theory all of the books published in Estonian should be annotated with these subjects. Subject is also known as term or keyword or märksõna in Estonian. And doing this automatic manually is time expensive. In the National Library of Estonia, finding keywords or subjects for a book takes 15 minutes. So only 4 books in an hour. And it's also subjective, meaning that if two different people are labeling, then they usually don't agree on what terms to choose. And also when processing scientific books, a cataloger who is not an expert in a given discipline is not able to correctly and precisely understand and describe the topics contained in the book. So we can't assume that these workers in library who are labeling and cataloging the books know everything about all the different science fields and know what is the best term to put. And so National Library of Estonia had a tender to test whether the automation of the process would be possible, if it might save time and money, and if this KRATT could help to raise the quality, and if KRATT could be integrated into the daily cataloging workflows. And we won the tender, and this is what I am going to talk about, the results of this tender. So if we want to start with this task, we have 2 main options. We can choose keyword extraction where keywords are chosen from words that are explicitly mentioned in the original text. Or we can choose keyword assignment where keywords are chosen from a controlled vocabulary or taxonomy. And as all the chosen keywords should be present in our database in the subject thesaurus, the latter technique is more suitable for the following methodology used for subject indexing. So we chose that one as we have the controlled vocabulary already. And the data we had to work on, the National Library of Estonia provided around 8,000 publicly available books with corresponding subject indices for developing the prototype. So we already had books that had been manually labeled. We knew what are the preferred terms to these books. All the books used for developing the prototype are available in digital archive DIGAR and the corresponding subject indices in the national bibliography. And also we have their various languages, but Estonian is the main one. And what is maybe interesting that almost all, 93% of this dataset is from 20th century or the last 100 years. So we don't have to expect any differences in the wording so much. And what we have dissertations, reports, brochures, manuals, textbooks, collections of articles, transcripts, dictionaries, and novels, short stories. And I think this is a bit different from the other similar works where usually only dissertations and articles are used. But we have all of the data that are in the library. And this subject thesaurus has types like gender and form, time, location, and topic. These are the ones that we included in the prototype. And subject types like person or collective or organization or temporary collective or event are not based on this thesaurus or any other thesaurus, and it would have needed additional pre-processing, for example, merging differently written preferred terms referring to the same entity, and therefore we excluded the labels belonging to these categories from the prototype. So we had only 3 types of subjects that we tried to predict to new books. So easy, we have already the taxonomy and we already have the data that has the manually labeled with manually labeled subjects. Should be easy to do it automatically. We came across various problems. For example, we had in the dataset very long inputs. The extent of the books varied from 1 to almost 2,000 pages, with the mean number of 86 and the median number of 52. And also, I haven't mentioned how large is the thesaurus. In Eesti märksõnastik, there are 61 unique preferred and non-preferred terms. And only 9,000 of the preferred ones are in our dataset. We just don't have data with all of these terms. And also, one subject has on average 1 to 4 books in the train set. And this is extremely low to train any kind of classifier. If you have only 4 examples for one class, I mean the term or the keyword or the subject, you can't expect much, or usually it's better to have more. And the largest amount of one the largest set of keywords one book had was 35, and the smallest is 1. So this is the way it varies. How we tackled the long inputs and the fact that one subject has on average 1 to 4 books in the train set. We tried segmenting, which is splitting by pages and annotating the book's subject each page. For instance, if a book with 456 pages would have contributed 456 examples to every label, it had been assigned. And it should be noted, however, that this approach had a drawback. Some of the books in the training set consisted of multiple unrelated sections, like article collections or short story collections. And therefore, we would have some pages that annotated with the term that it actually shouldn't be. And moreover, each label assigned to the book might not have represented every page of the book equally, even if the content distribution in the book was more or less uniform. We expected that this noise would not have noticeable impact, and I think we can, in the end of the lecture, decide together if it's true or not. And here is just a graph how we take documents related to a term or subject M, and then for each page we add that this page is with the subject M, and therefore we have a lot more larger data set. And also, which we didn't try because we didn't have time, but we proposed that in the future maybe a clustering might be a possible solution. For example, if I have a book with forestry and fishery, then we could find out which pages are more related to which term. After splitting the documents and treating every page as a separate instance, the number of examples by keyword increased considerably, with a median frequency of 393. We set the minimum number of examples for each classifier model to 50 to guarantee sufficient number of examples for each keyword and obtain the final label set of size 8003. So now we have training set that consists of short enough text that it wouldn't crash our computers, and we can start building a classifier. Of course, another problem arises quickly. We have 8,000 different classes to build a classifier for, and this is computationally quite expensive. For example, if I train binary models and I want to know which models are which models predict true to this certain book, then I should ask from 8,000 binary models, what do you think, and then get the highest confidence. And this will take ages, and it would be better to do it manually than if you look at it time-wise. And yes, so we used our hybrid tagger that is developed in TEXTA. It's a binary model. It is, how do I explain? Hybrid tagger is part of TEXTA Toolkit, which is a toolkit we developed in TEXTA, and it's used for data analytics and text analytics, and we can see it a bit later. And the hybrid tagger is part of that. And hybrid tagger enables to reduce the set of candidate tags significantly by comparing the input document to the other documents from the same domain indexed in Elasticsearch. Elasticsearch is a kind of database that is quite good with storing and storing textual data, and it has this option like more like this, and it retrieves documents similar to these documents that you asked for. So we could get, if we put this our new book in, we ask Elasticsearch to have most similar documents to this text, and we get this. We then collect tags from these documents we retrieved, and tags of n most similar documents we can take, and then use the ask only those tags binary model. So we exclude. So this is like 400 times faster because we don't ask for 8,000 binary models. What do you think? We ask for about 20 binary models. What do you think? And that makes it computationally faster. And yes, this is this cool hack that we used and got rid of this problem. And also the problem of having, we have the binary model dataset where one term has one page. But if you give in the whole book, it also can crash the computer because, as I mentioned, the books can be 500 or 2,000 pages long, and it's not necessary to ask to give the entire text. Because the time it takes to automatic subject indexing tool to predict the keywords grows with the number of pages to process. And at some point, it's just faster to do it manually. And the results stabilize after a certain page limit or even get worse if the number of irrelevant labels grows. So this table shows this test we did to determine how many pages of the book we should pass to automatic subject indexing tool. We analyzed how the recall scores changed while incrementing the number of pages. And we ignored F1 score-based performance at this stage, as we used another method addressed in the next paragraph, other method for specifically optimizing precision. As the number of pages it takes for the result to converge might differ depending on the extent of the book, we constructed 5 classes, you can see in the table, and selected 20 random samples for each class. And on average, it took 34 pages to fully converge here, but only 6 to reach to 90%. And moreover, the 90% was always reached after using the 10 segments, regardless of the book extent. So we found out that if we only select randomly 10 pages of the book, we can already get over 90% of the recall. And since it's computationally much faster, we decided to stay on this 10-page rule, as it ensures a very time-efficient subject indexing process. However, we decided to leave the user an option to modify it. So in case you have a long book and you want to make sure you get all the terms, so you can choose a higher amount of the pages the models actually test. And then we have this threshold, which is the number of pages the keyword was predicted to, divided to the number of pages used. Usually the number of pages used is 10. And the threshold was 0.4. And why we had this threshold is that the average number of keywords added by the catalogers themselves is 8. Meanwhile, the average number of keywords added by our hybrid tagger is 52, and that's too much to sort out. And to retrieve fewer or more precise results, then we had this threshold. And this can also be modified, and you can see in the graph that the threshold 0.4 is more similar to the actual usual amount of terms that are added. And also the problem of that training data doesn't cover all possible terms from our thesaurus. It is unsolved because you actually have to train a binary model for each term. And this is, can be solved just by adding more books. And just to explain it more clearly, I jumped from one topic to another, how it works. So the user gives in a book in a PDF format or a brochure or whatever he or she wants to annotate with subject. And it is converted to PDF with Apache TEXTA, I think. Let me check where it is. Yeah, Apache TEXTA, which is an open source tool supporting text extraction from a wide variety of formats, including images requiring optical character recognition. And if we have this in textual format, we split it into pages. And then we take the amount of pages that we chose, and usually it is 10, as I mentioned, but additional 5 pages are used as a buffer in case some of the selected pages do not pass quality control. And the quality control is here. This is a hidden Markov model based on the distribution of character sequences to distinguish unsuccessful text extraction. So in case the Apache TEXTA extracted pages, which consisted only of random symbols that doesn't mean anything, then these are selected out and just thrown out, and that is why we have the 5 additional added to the user selected 10 pages. And if the text is validated, we move to our TEXTA multilingual processor application, where we detect language, extract lemmas and part of speech tags. And TEXTA MLP uses this TEXTA MLP that is used here uses SNLTK and SPACY. And I guess I don't have to say what are both part of speech tags and lemmas, but these are just an additional information for our models. And if we have extracted all this information, we can feed it to our hybrid tagger, which, as I explained, looks at the pages, retrieves similar documents from our dataset, and then sees the top n most tags, the most frequent tags in these documents. Usually, I think it was 20. And and then it takes those 20 tags models and predicts for each page if this tag should be annotated to this page. And then we order the tags by frequency and also have this threshold. And then we have the set of subjects that we wanted. So I think it's pretty easy and logical for a prototype. And also now the most interesting part, does it work? To evaluate the results, we applied the automatic subject indexing tool with default parameters. to 350 new books that were subset indexed by the catalogers during the 6-month period after finishing the prototype. And the distribution of forms, genres, and extent of the books was similar to the training data. However, the language distribution deviated from the original, with only 59% of the books in the test set being in Estonian, and that is almost 30% less compared to the training data. And also other languages in the test set included English and Russian and others with higher percents. And the books contained almost 1,500 unique preferred terms, of which only around 1,200 were present in the training data while developing the automatic subject indexing tool. And we excluded all the keywords not present in the training set while evaluating the test results to get a better grasp of how well the model predicts keywords. We compared the subject indices added by the catalogers with the keywords predicted by the automatic subject indexing tool and calculated precision, recall, and F-score for each book. You can see them in this figure on the slide. The overall scores were then calculated by averaging all the individual books' scores, and the distribution of resulting prediction scores on thresholds 0, 0.2, and 0.4 can be seen there. And you can see that the best average F1 score was 0.3, and it was reached equally on thresholds 0.2 and 0.4. You can see it here. With the first providing higher average recall and the latter providing higher average precision. You can compare them here. And although the scores are underwhelming, there are several possible explanations and or ways of improvement, as F-score 0.3 is not high. For example, as I mentioned, that maybe this noise would not be with high influence. It can be that it has more considerable effect than we originally expected. And one possible solution for improvement is to map only a relevant subset of the labels with each page and retrain the models. So as I said, maybe clustering or some other way of doing it. And also a little critics for our method. Although the number of examples per keywords increased remarkably after splitting each book into pages, the number of unique books linked with an average keyword still stayed the same. And this might have led to overfitting on the features tied to the content in the limited number of the books. The best solution for this problem is to, of course, use more data, which could be accomplished by including the copyrighted books, which were not available during the development of the prototype due to legal complications. And also, we should consider that the labels added by the catalogers used for calculating the scores are subjective to some extent. Even the labels chosen by two different catalogers might not fully coincide, and furthermore, the subject indices are not usually 100% correct or 100% incorrect. There exists a gray area consisting of keywords which are more or less adjacent to the topic, but considered excessive by the subject indexing methodology followed by the catalogers. And therefore, we did another test to just figure this out. 5 catalogers working in National Library of Estonia tested this tool with 20 books each. The catalogers did not consider the results satisfactory and claimed that the results are rather causing extra confusion. If the prototype suggests a keyword originally not added by the cataloger, it takes the cataloger additional time to find out if the keyword proposed by the tool is actually relevant to the book's content and if it should be used in the subject index or not. And these results, we discovered, are in alignment with the survey investigating the attitudes of German and English-speaking librarians towards automatic subject indexing. The results of the survey showed that the librarians assessed the quality of automatic subject indexing system with skepticism, and over 60% of the respondents believed that machines will never be able to outperform humans in this task. So you might expect a little hostility or this fear that maybe we develop something that takes over their job. And we also tried another way to figure out if those terms are good or not, or the KRATT's results are good or not. We asked from regular users to do this test. To determine how the regular users perceive the results, we randomly chose 10 books from the test set and let the 6 users evaluate the results based on this criteria presented in this table. So they gave 1 if all the keywords are irrelevant and do not represent the content of the book, and 5 if they think that this set is completely perfect or almost perfect. And yeah, it's only 10 books and 6 users, but it might give some kind of idea how regular users evaluate the results. And to make sure that the randomly chosen books are representative of the test sample, we plotted the data points of the books and on a figure representing the average prediction scores depending on the extent of the book. And as most of the data points stay below the lines representing the average scores, we are confident that the chosen books did not distort the perception of the results of the KRATT. We presented 3 sets of subject indexing results for each book. Let me see, you can see them here. The original labels added by the catalogers, this actual keywords. The labels added by the KRATT after using 10 pages of books, and the labels added by KRATT after using all the pages of the book. And the threshold is much lower here. And the results are grouped together and given here. On average, all users evaluated the keywords added by the catalogers higher than the keywords assigned by the KRATT. So catalogers were got better points from our regular users as well. However, there was a noticeable difference between different subcategories. While the topic keywords added by the catalogers were considered better by the KRATT's result, then KRATT outperformed catalogers slightly with the prediction of chance. You can see it here, just slightly though. It is also worth mentioning that meanwhile the time keywords added by the catalogers had a higher average score than the keywords suggested by KRATT in the same category. The catalogers added time keywords only to 2 books out of 10, and KRATT predicted time keywords to 5 to 6 books out of 10, and still received relatively high evaluation scores. Here you can see from the users. As KRATT's average results predicting the keywords is slightly over 4, we can conclude that the user's perception of adequate keywords does not necessarily mirror the cataloger's perception. However, it should be noted that this specific evaluation process measured only how well the keywords were able to summarize the book, but this is not the only purpose of these keywords. They are also used for searching information from the library's databases, and while a couple of false positives or false negatives may not have a significant impact on the general overview of the book, they can negatively affect the user's experience while using the database. This also helps to explain the disparity between the users' and catalogers' opinions, as the latter group is used to considering all possible implications of this label set. And also how this KRATT's prototype GUI is looks like. You can put this book's URL from Digar, I think, or choose it from your own computer, upload it, and choose this amount of pages you want to put into this predicting process, and then you click on predict the keywords. And currently it takes KRATT about 1 minute to predict keywords for a book of any size with these default settings. And as we have this option to take only 10 pages out, then this length of the book doesn't influence this predicting time anymore. And then it predicts or suggested these different keywords. This is topic keyword, this is location keyword, and then this user can unselect them or not and use keywording option. And also there is an option to see in which language these pages are. And this is unsupported language, it says. And here, maybe to see ourselves, what do we think about these results? We have this book or brochure about Estonian citizens' income profiles. You can see it has this income, finance, resources, pension, something about groups, this kind of text, and the actual keywords by the annotators are given here. Unfortunately, I only have the Estonian version, but it says like analyzing or saving money, pension systems, and here is the results of our KRATT. You can see here is Estonia, education, youth working, social, how do I translate it? Investigations, and you can see that one of our users estimated with 5 that this cataloger's results is better, and with 3 meaning then fair amount of the keywords are relevant to the topics covered in the book, but there exists a sufficiently significant amount of irrelevant keywords to go, and this causes confusion. And also we can see with keywords, place or location keywords, interesting to see that we have two versions of Estonia here, and the library only bought one, but we found both of them. And also the genre, where actually this was considered better than the one that catalogers thought. Also, it's very subjective estimation. Yes. And we can perhaps see another more. We have this book called Sakala Partisandid, this one type of soldiers. And you can see we have some difficult text. I guess these were just thrown out. But this is historical war text. And it's almost 500, it's 400 pages long. And it talks about the Estonian Freedom War that is mentioned in everywhere as the first one. The order is frequency. And then the next is history, partisans, battalions, war history, soldiers, and what is väeüksused? Units of soldiers. And what is different, and here is also had that education history, home story, cultural history, then küüditamine, which is deportation, families, repressions, for history, and this väeüksused is also here the same. And maybe it's interesting to see that also we have here only Estonia. Here we have Soviet Union, for some reason, Järvamaa, which is one county in Estonia, and then we have Eesti. And then here we had no time given by the actual catalogers, but here the 20s, and after that is given here. And here it's said it's memories and lists, but this says biographies and memories, which is maybe interesting to see. And also the last one is Estonian National Poem Science History. Very, not the oldest book, 2016. No, sorry, 1961 it was published by Laugaste, and it looks like this. Talks about Estonian poems and its history. And catalogers said that it gave the terms folkloristics, folk poetry, and science history, and e-books. But here the KRATT thought it should also have tags like history, Estonia, Estonian, folkloristics, this is the same, cultural history, folk songs, folk poems, folk poem scientists, and so on. And it came more. But it's so subjective to say that which set is actually better. And there is no right answer. This user estimated that this subject set is better, but the catalogers thought that this gives the better overview. So it's very hard to estimate, but I hope that this gave you some example how well or bad the KRATT works. And this was only the prototype. We are continuing with it and developing it, and we are currently testing new methods, how to tackle this issue, and even maybe better to do. And just as I mentioned for a second, the TEXTA toolkit, I'll spend 2 minutes on it because I feel that digital humanities can would benefit a lot from it. This is an open source software for building RESTful text analytics applications, and it is developed by our company. The documentation is here, and it's free to install and download. It has Docker image, so it should be pretty convenient to set it up and running. And it can be used for several things. It supports now almost all the workflow of building classifiers. We are hoping that soon we can even add this option to manually annotate texts, which we don't have currently. But other than that, we can, for example, we have topic analyzer, which from which we can search for clusters and tag them. for later building classifiers. And also we have different classifier options here. Tagger groups is actually hybrid tagger. It's just under a different name. And we have paired taggers. We can build embeddings here. And we can also use regex as a form of tagging in case just neural network or machine learning models, other machine learning models are too much if we know that we want only certain words or regex patterns will do it. And also we have these things like anonymizer that is used in Riigi Teataja, where we anonymized a bunch of legal texts. We anonymized these people's names. And it was actually a pretty complicated task if you think about it, that the names can occur several times and you can have, for example, brother there. And if you have like Jaan Tamm and Juhan Tamm and then comes Mr. Tamm, you don't know which Tamm it is. And also recently we had this cool thing, summarizer, where you can summarize text for example, have a quicker overview of your dataset. And the evaluator is for evaluating the results of our classifiers. So this is also part of this training classifiers workflow. And I think maybe the most useful one I have here, Express articles that are actually published and available under the Embedia project we are collaborating with. You can conveniently search for texts from a very large data set within under a second because of Elasticsearch. It provides that, and also we can aggregate the text and do time aggregation, for example, to see the frequency of articles, including a certain term, for example, if I put Andrus Ansip, I can see how the timeline goes up and down on certain times when he was doing stuff that in the articles was written about a lot. Yeah, so this is just a small, short advertisement that it's a cool thing, it's free, and it's worth trying out. That's it from me.